Welcome back, Senior Girl Scouts. This is Mrs. Lori, your virtual program coordinator, and I'm coming to you today to help you with step 3 of earning your Science Space Expert Badge. And today we're going to learn and talk about telescopes, and we're going to do a really cool science experiment to help us determine the amount or the area of light that is let in through the lens of a telescope. So you're going to need some household supplies today. You're going to need some beans or lentils. I'm just using regular dried pinto beans, as you can see here. But you can use lentils or a bean of your choice. You also need some blank sheets of paper, 2 preferably, and a drawing compass if you have it. If you don't, that's fine. You can actually use a regular size ruler with inches. Make sure it has inches. And you can use this to also create lines of diameter and then trace some circles. So if you don't have a drawing compass, that's okay, but this does work really well. And you'll also need maybe a marker to outline and a pencil. I definitely use the eraser more than anything on it. So these are the supplies that you're going to need today, and possibly a science notebook or somewhere where you're keeping all of your scientific badge work. I recommend keeping an area where you can make a chart similar to this one. So let's go ahead and get started. One thing that we know about telescopes is that they basically allow the sun's light to come in, or any light to come in, and it reflects off what's called a mirror, and it basically reflects an image into our minds. So that's what we're able to see. Today we're going to do an experiment to kind of test out the amount of light that, or the area of light that is let in through telescopes. So what we're going to do is draw some circles using either your drawing compass or your ruler. And as you can see, I've created 2 circles here, or actually 3 on this one. This circle represents about the size of the pupil of the human eye. So the diameter of this circle here was about 1/4 inch. And make sure when you're using the drawing compass that you realize that the point of the drawing compass is placed down from the middle of the circle. So actually you're only looking at the radius of the circle, so you have to double it. So for example, here when I created my, about the size of the lens of a binocular or a set of binoculars, that is 2 inches in diameter. So I made sure that my drawing compass, the radius was set to 1 inch, so that when I created the circle, it made a 2-inch diameter. So radius is half the length of the circle. The diameter goes all the way across. To create about the size of a small backyard telescope lens, that's about 4 inches in diameter. So that circle is there. And then lastly, I created a large circle. This took up about 1 whole sheet of paper to represent the lens size of a large backyard telescope, and that is 8 inches in diameter. So going all the way across, the diameter is 8 inches. So once you have these circles, what you're going to do is actually take your lentils or your beans and fill up the circles to see how many of these, or an about estimate amount, how many will fill up each of the circles. Now I've already done this part of the experiment just to move things along a little bit, and I will put in some pictures at the end of the video here so you can actually see where mine was completely filled up. I also tried to work a little bit smarter, and I tried to fill up half of my circle and then just take that amount and double it to see how much area or space was covered by the beans or lentils. So as you can see here, I've recorded down some data. The data that was given to me was that a human eye, which is about 1/4 inch in diameter, would represent an area of about 1 bean. So the human eye, a fourth of an inch or a quarter inches in diameter would equal about one of these. One area, one bean. So then I decided which actually equaled out. It took about one bean to fill up this entire circle. Then I filled up my binocular circle, the 2-inch diameter circle, with beans, and I counted 20. It was able to cover an area of 20 beans. So basically that means that when the light enters the binoculars, it's able to cover about an area of 20 here. Backyard telescope, the diameter was 4 inches, and I counted 64 beans in that circle. So the 4-inch circle, I covered this one and I counted 64 that it was able to fill up. And then my 8-inch circle here, 8-inch diameter circle, I actually filled up half of it with beans and then just doubled it to cover the entire area. And I got 334 beans. So then you should ask yourself, what trends do you see here? What pattern are you seeing? Obviously, you should notice that as the diameter increases or the size of the circle increases, that the light is able to cover more area, which makes a lot of sense. We want to see more of an area of, let's say, a planet or a constellation in the sky, then we're going to need a larger circle or a larger lens. We're going to need a larger telescope. Then I was posed with the question of, the James Webb Space Telescope is about 256 inches in diameter. And I thought, well, my drawing compass and my ruler, it would be very difficult to draw a circle with 256 inches in diameter. So I decided to think about this mathematically. And that's why I said today, you need to come with your critical thinking cap, because you're going to have to do a little bit of mathematical equation here to kind of figure out an estimate of how much area would a telescope this large in size cover. So I thought mathematically a little bit, and I knew that the area would be a large amount. So I thought to myself, if 8 inches in diameter of a circle covers about 334 in area, 334 beans, I decided to figure out, well, how many 8-inch intervals are in 256? So I took 8 inches, I took 256 of the diameter of the Webb Space Telescope, I divided that by 8, and I said that 8 goes into 256 32 times. So then I said, well, if 8 inches is 334 beans, I take 32, multiply that by 334, and it should cover an area of about 10,688 beans. However, the reason I wrote about is because this is just a scientific experiment. Obviously, you're going to have variables that are different. So you may have decided to use lentils instead of beans. My beans are definitely larger than the size of a lentil. So everyone's experiments are going to look a little bit different. But ultimately, everyone should come to the same conclusion that as the diameter of the telescope increases, the size of the area increases, the more light that is allowed to be let in. So hopefully you were able to learn a lot and use your mathematical brain today to understand the amount of light that is let in through telescopes and just how powerful telescopes really, really are. And maybe a takeaway from this experiment is exactly what type of lens should I be using to look at a particular object. If I'm trying to find a planet or a constellation, obviously I'm going to want to let in more of an area of light, so I'm going to want to use one of these larger telescopes. I think another takeaway would be to learn a little bit more about the James Webb Space Telescope. So I encourage you to go out and do a little bit of research on your own about just what that telescope looks like and how large it is. When we meet again next time, seniors, we are going to take a look at a fun science experiment on learning about light exposure within darkness. So we're going to do a fun science experiment involving actually your smartphone device. So you'll want to make sure you bring that next time. And also a simple household flashlight. So we're going to do a fun experiment with that to learn about light exposure within the darkness of space. So far, things that we've been able to cover and take away for our space expert badge, or maybe we've become more of an expert in, is uncovering what we're made of. So the stardust, that was step number 1. Step number 2, we studied the brilliance of stars and what they look like by creating an awesome looking scrapbook to share with friends and family members. And now we've become a little bit more of an expert in light exposure within telescopes. So we've got 2 more steps to go. Like I said, the next time we'll learn about the exposure of light in a dark room. And then step 5, finally, we'll be able to learn how to share all the knowledge that we've learned to really become an ultimate space science expert. Look forward to seeing you next time. Bye.